All right, let's keep on keeping on. Still review here. In section 1.2, we're going to be representing functions. So just the basics that go with this. The first type of function we're going to talk about are piecewise functions. Remember those? Where you're taking a piece of this, a piece of that, all of this together makes a single function. So here's an example. If I have something like, I don't know, x plus 3 if x is greater than or equal to 1, and x minus 4 if x is less than 1. So here's the kicker, right? I've got this line, but the line up here only goes for the x values that are greater than or equal to 1. I've got this parabola, but it is only accounted for with the x values that are less than 1. Right? Because remember, the definition of a function is the x's can't repeat. Right, so you see this now? If x is greater than or equal to 1, those are the only values that work with that piece. When x is less than 1, those are the only values that work with that piece. So let's just say if we are asked to evaluate this, what if I want to find f of 1? Am I going to be plugging that 1 into the top or the bottom? The top, good, because it's an or equal to situation here. So I have 1 plus 3, so f of 1 is actually equal to 4. So the coordinate point on this graph at 1 is the point 1, 4. Okay, and it's a closed circle there. All right, then what if I say, I don't know, 0? Am I plugging 0 into the top or the bottom? The bottom, good, because 0 is with this interval, so I plug that in. So 0 squared minus 4, f of 0 in this instance is actually negative 4. When you go to graph these piecewise functions, you could look at this as f of 1, and I plug that in here. So f of 1 is equal to a negative 3. This is going to be an open circle, right? Because my graph actually goes all the way up to that 1, but just not including, right? So up to, but not including, because it's x is less than 1, it's not including, so that has an open circle there. Does that make sense? Okay, I just want you to have general ideas associated with this. You are going to be given a graph on your homework, and you have to decide which one it is. So can you graph a parabola at this point? Can you graph a line? Which graph best represents that? Look at your slope. Is it positive or negative? What are the values at these cutoff points, right? Those kinds of things. I want you to just have a general working knowledge. That's all I'm going for right now. So piecewise is the first type of function that we're representing. The second type of function that we're looking to represent are power functions. Right? Squares. Exponents is what I'm trying to get at. Right? So any kind of power function. If you're looking, so think back, if you have an even power, what do you know about that end behavior? Same direction, good. End behavior is in the same direction, whether it's up or down, right? We'll talk about transformations in a little bit. But here you have to the 6th to the 4th squared. If that power is even, then it's going in the same direction. If you have an odd power, what do you know about that? Yep, nailed it. In behavior is the opposite. Opposite, learn how to spell, step 1. Direction. Right? And again, we'll talk about transformations, but this is going up, opposite direction from down to up, cubed to the 5th to the 7th. Right? So power functions we're looking at. Even is the same direction, odd is opposite. Again, generalities. Generalities, that's what we're going for here. Do you have the basic working knowledge of what these graphs look like? If you can have power functions, then you can have root functions. Let me move this little fella on up here. Try to be in advance here, right? Get these images in here. Okay, so if we can have power, we can also have root. Remember, when I'm talking about a root function, just like we talked in 1.1, right? There are domain issues. This is a rational exponent. Don't you remember y is equal to x to the 1/2 is equivalent to the square root of x? Yeah, okay. Just making sure power over root. Remember, power is to the first power. The root, my index here, is squared. Okay, so it's just represented a different way. These are all even roots, right? Even roots, you can't have that negative underneath the radical. So it starts at 0 and goes on from there. If it's an odd root, then sure, you can have a negative under the radical, and that's what makes it infinite for that domain. Okay, general working knowledge. General working knowledge. That's what I want to impress upon you today. Get that general working knowledge. Okay? Then, lastly, we're just going to briefly talk here about rational functions. Our rational functions, the kicker and the defining characteristic there are those asymptotes, right? You can have horizontal asymptotes or slant asymptote, right? Horizontal or slant asymptote, depending on what that degree, right? That leading behavior, that degree is going on. Or you can have vertical asymptotes or holes. Remember, we talked about that in 1.1 too. If you have a hole, that means that it cancels from the top and the bottom, and it can put you in that hole. Or your vertical asymptotes deal with that denominator. So your horizontal and slant asymptotes, you're looking at the degrees, right? Same degree, bigger on top, bigger on the bottom, all those kinds of things. You remember that from algebra? And then holes, you're looking at the denominator for the vertical asymptote, or if they cancel like we did, that's where you get those holes when you factor that stuff out, right? Basic working knowledge. That's all I'm going for here. You had a whole class on how to manipulate these. Where right now is just dealing with basic working knowledge. All right? So basic working knowledge of these kinds of graphs. So take a look here. Consider the graph of this function. We want to answer these following questions. So this is obviously a polynomial, right? What I really want you to look at and focus on, what's happening to my graph, right? What are the basic characteristics? Like, which points correspond to the roots or the zeros? Just in the letters. Yes, so a root or a zero is also called an x-intercept. All of those mean exactly the same thing. So if I'm looking for my x-intercepts, A, D, F, and I, good. Good, those are my x-intercepts. All right, which points on the graph correspond to high points or peaks, and we will actually be calling them maximums. Yes, there's only one. Good for you. It's at E, right? Because here my graph peaks up, but this goes on forever. This goes on forever. That doesn't peak. The only peak or hill or maximum I have is right here at E. Good. This is vocabulary that I just expect us to know moving forward. Okay, what happens if I have a local minimum or a low point or a valley? Where are those happening? Yeah, good. This one has two. At B, comes up, and then we come back down here to H. Good. So B and H, both of those. You guys are awesome. Nice job. Okay. What as I move along the curve in the positive x direction, at which point is my graph rising most rapidly? So this is decline. Here I'm rising, but here I'm declining, and then here I'm rising again. So where's my graph rising most rapidly? Yeah, I would say I also, right? Because if I'm looking at this, it's going up pretty quickly. Good. And we're going to talk a lot more about that, what that means when we start talking about tangents and derivatives. Just so you know, spoiler alert, this awesomeness is coming at you. As you move along the curve in the positive x direction, at which point is the graph falling most rapidly? Yeah, probably A, right? Are you seeing that too? If I'm coming here, this looks like it's steeper than here at G, especially here at H or even at G, right? That's falling, but I wouldn't say this one is more rapid than this. This looks more rapid, doesn't it? Yeah, I agree. Good. So we're looking at A there. Nice. Characteristics of the graph. That's what we want to go for. General working knowledge. I can't impress that enough.